As you said, I'm here to introduce MotoROS2, real creative name, I know. It's developed by in collaboration with myself, in collaboration with Heish Vanderhorn from the Delft University of Technology. Truth is, he's the brains behind this whole thing. I'm just the good looks. So, but we been developing this for about 2 years now, and I think it's ready to go. So, a little bit of overview on this. As far as we know, it's the first native ROS2 node to actually run on an industrial robot controller. So it's on there, ready, it's running at all times. We use the RCL and RCLC libraries, so we're using actual ROS messages, actual ROS APIs. What we do is we install it on the robot controller as what we call a MotoPlus application. What MotoPlus is our SDK for developing an executable that will run directly on the robot controller's CPU board. So you don't necessarily need an additional PC depending upon what your application is. And in this case, you would because it's ROS. But we do have one component that does run on the PC itself. As I said, we're using micro-ROS. I'll get into that more in just a moment here. But the component on the PC is very transparent. It's not Motoman specific at all. You just run one line of your command and it just magically works. This is compatible with any robot model, but it is currently only on the YRC-1000 and YRC-1000 microcontrollers. That'll probably soon be expanded to backport to older controllers, but that's what's available now. You can have up to 8 concurrent arms and or tracks, stations, whatever you want, public control groups, and either of our teach pendants will work just fine with it. It's kind of, if you got the newer tablet style pendant or the traditional volt style one. So I mentioned this node is built on micro-ROS. The guys over in Iprosima, I don't know if I'm saying that right, place out of Spain, they create this micro-ROS standard, which the target is to run actual ROS in a resource-constrained environments. This, microcontrollers, basic operations. MotoPlus itself is not necessarily a microcontroller by any means, but it is limited in resources as far as memory, as far as language. No C++. It's an old compiler. It's a lot. We would not have been able to just take like a PC ROS node and just slap it on the robot controller. So this is the perfect gateway for us to build upon. And at the bottom here, I mentioned micro-ROS agent. That is the component you run on the PC. It's kind of like a bridge, but it's completely transparent. Like I said, no Motoman specific changes to it. You just run their Docker image, and it just magically works. Because it is done by Iprosima, they're also the guys who did the ROS middleware layer of FastDDS. So if you are communicating using some other RMW, it won't work. So it's kind of one of the open issues. We're investigating options going forward in the future. But point is that you do need to use a FastDDS standard. So if you're on that one, if you're using Cyclone, it's not going to work. So like, for instance, if you're on Galactic, the default is Cyclone, but then back to Humble, it goes back to FastDDS. So we're good there for now. As far as distribution, source code is open source on GitHub. There is a closed source library in the project. It's just because we're reading some parameters out of the robot controller that we're not allowed to publish. So we kind of obscure it and just set give you a function call such as getting the speed limits for each joint, stuff like that. It's just in trying to hide the parameter numbers all. But source code's available. You do need what we call our MotoPlus SDK to actually build the project. For users in the Asian regions, they would normally, if they were to try to get the MotoPlus SDK, they would get something called MotoPlus IDE, which is not compatible. So Asia region customers need to talk to Yaskawa America and get the US MotoPlus SDK. However, the license is identical. It's a little security USB dongle. You can just literally install the SDK and your Japanese dongle will work fine. So no big deal there. So again, open source, you can download it. You do have to buy the build tools. If you don't want to do that, the binaries, pre-compiled binaries are available on GitHub for download. You only need the source code if you want to make changes to MotoROS itself. So if you were wanting to add like a new publisher or something like that, that would require changes. But if the ROS API we exposed to you is good enough, it's all free. So the micro-ROS layer, the communication layer, we built it upon a special fork to make it run in the MotoPlus environment. That is currently closed source, but we're working on using more upstream branches that don't have any secrets in them. So, and as far as support packages, we have a large library of ROS-I that very easily converted over. If you got a new robot that comes out, just ask for it on GitHub and somebody will get it. So YRC1000, YRC1000 micro, any robot model. We're going to try to port it back to DX200 and FS100. We have no plans to do DX100. It's compatible with ROS versions. We are Foxy and Galactic are end of life. So once that breaks, it breaks. Irwin is not yet compatible because we are reliant upon the micro-ROS layer, and that's not yet compatible. So we'll see what it takes to get that all brought up to speed. So this is kind of just a listing of the API that we're publishing and what we're accepting. We try to use standard messages whenever possible, standard joint states. We did use the ROS, we modified the ROS industrial robot status messages and that's what gives you stuff like whether you're in an air state, whether you've got an e-stop, if it, motion ready, that kind of stuff, just telling you the general status of the arm. We do publish TF directly, but it can be configured to be turned off if you want to do it through other means, like what's that, a joint state publisher. We do accept a standard follow joint trajectory and a standard output from Move It. There are limitations to that, though, I'll get to in a second. And then we have a number of custom services as well that are, kind of Motoman specific. Mainly the start mode ones, those are kind of the important ones there. That's kind of the enable signal. So if you want to turn the robot on, you call it, power on the controller, you call that service, it's going to enable servo power. It's going to start a required job on the controller, and it's going to just put it in a general ready state. So trajectory point is a new one that we've added due to limitations of the follow joint trajectory action. We'll get to that in a second as well. And then we can read and write IO and select tool for like safety files and stuff like that. So if you've got different functional safety limitations based upon, if I've got this tool or that tool, you can control those via the service. There's just a little more detailed on the publishers, which the publish rates are configurable. So if you want to go faster or slower, it's all up to you. Standard joint states, nothing new there. The robot status, like I said, is our custom one, but it does list, any errors that are active in the system, so that it can, just tell you if you're good to go. And then TF, we are publishing directly. Again, that's a bad image because I got two robots, but I didn't calibrate them. But if you calibrate the robots to each other, it will be on separate branches in the tree. Like I said, reading, writing IO and registers, setting the tool number, and enabling the motion control. Kind of blow up, but these are all the custom MotoROS2 interfaces. So it's all our custom messages. We have a single package called MotoROS2 client dependencies that you can download. And that you basically download that and then run ROS dep on it, and it pulls all this stuff down for you. So there's all clear instructions step by step on the README on the GitHub page. So I mentioned kind of your standard follow joint trajectory and the new kind of motion style. The reason why we have the two is that micro-ROS has some limitations as far as data sizes. So basically, once you max out the payload of a UDP packet, it just disappears after that if you try to go any higher than that. Through some various testing, we found it to be pretty reliable with up to 200 points. So that's our magic number that says if you're doing something on Move It, your trajectory has to be 200 points or shorter. You can continue to submit additional trajectories afterwards. So move here, 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 move here, here, here. But you have to come to a full stop after each trajectory. The alternative is our infinite Q trajectory points service. So it's the exact same data that's in follow joint trajectory, except it's individual points at a time. And you just keep streaming those into us and we'll just keep on moving. And so you can just, with that, you can do an infinite, just go as long as you like. Oh, I think we have an example somewhere of converting from, if you have like a long output from Move It, converting from follow joint trajectory into Q trajectory point. So we have ways around the limitations if need be. I mentioned that there is some configuration available. So this is a YAML file that gets loaded into the teach pendant on the robot controller. And we have defaults for basically everything there except for the IP address of your PC. But in here, you can configure stuff like your publish rates. You can configure your QoS settings. Because there are issues, for instance, with like if you're publishing TF, RViz expects one QoS, Move It expects a different QoS. And if you pick the wrong one, it just flat out doesn't see it. So this will allow you to kind of customize it for your application if need be. You can also customize your domains and stuff too. So if you've got like multiple systems on the same network, this will allow you to separate them out. You can rename the node. You can do whatever you like with it. So as I mentioned, there are some limitations. So we are on fast DDS only. So Cyclone will not work with this or other ones. We have, like I mentioned, the QoS just now. We've also, that third bullet point is no longer accurate. That was fixed last week. So ignore that one. And we have limits on the message sizes, which is why I've got the various motion services. But yeah, if these kind of issues, what they lead to is just disappearing commands. You send something or you're expecting something out and it just doesn't happen. So something to keep in mind. Oh, by the way, I don't know if I mentioned this. This is technically still in beta. So because of these open issues that we have, we are calling it a beta. And we do plan to make additional changes and extend it, try to clean this up and make it more solid. But it is public, it's open source now, so that's there. Provisional roadmap, just in no particular order, supporting more controllers, reading, writing of variables if you wanted to interact with maybe control an inform job instead of doing direct motion control from your from ROS. We're thinking about maybe having like a custom GUI on the teach pendant just to show status and stuff on ROS parameters, logging. Managing inform jobs if you are doing a not doing motion from ROS, but just want to control something else. That's especially useful if you're doing process control, like arc welding, cutting, painting, dispensing. We don't have direct controls for that through ROS yet. I think that's on this list somewhere. But so many people will just create a general inform job that has these argon commands and all that, but they want to use ROS to control the execution flow of it. So that's an option available for you. Both the motion methods I mentioned earlier, they go through this internal buffer thing that we have. It takes the point and it breaks it down into little 4 millisecond interpolations and feeds it into the system at a high rate. Doing that does cause some latency, and you're not going to get like a really high bandwidth control of the robot controller. So one of the things we're thinking about is creating another entry point, if you will, into the application that lets you stream in as fast as humanly possible. Basically, you're bypassing that buffer. So that, we've had applications where people want to take, they want to do all the jerk limiting themselves and all that, and have at it. So use control for multi-robot applications. I don't know what that means. So one of the things we'd also like to do is, even though the agent is kind of transparent and you don't really notice it, we would like to try to maybe get rid of it if we can, and just have the robot controller talk directly without converting between R and W layers. So again, Aish was very instrumental in making this happen. It wouldn't have happened otherwise, and I broke many things in the process that he had to fix. So big shout out to him, and also the guys at eProsima. They offered excellent support for the when we found it had any issues with the micro-ROS layer. If you want to try it out, and I know some people in here were in the closed beta originally. Burn those files to the ground, go get new ones, and rebuild your workspace. Message definitions have changed, so there are some breaking changes. And any questions?
For questions, Ted. Akash. So if you have that 6 axes, is that 200 down?
No, that 200 limit was actually tested on a 13 axis system. So now, having said those words, if you go higher than that, it might possibly go down. And by might possibly, it will.
Oh, question is repeat the question.
Oh, I'm sorry. He asked if you have more than 6 axes, does the 200-point limit go down to do the message size? The answer is technically yes, but the testing was done on a 13-axis system, so that's where we got the number from.
So the performance of micro MotoROS2 with MotoPlus similar to MotoPlus itself, because I could just use MotoPlus and build my own Plus 2 right? I mean, what's the trade-off there?
So if you were to go just, he asked if the performance variation between MotoROS2 or using a MotoPlus SDK directly, there are, so in the context of not using ROS, you could potentially get much higher performance using MotoPlus SDK directly. But if you're using ROS, I would say that using this, this is as good as you're going to get as far as performance wise. And that includes, topic publishing speeds, receiving incoming points and processing them. But yeah, if bypassing all the stuff we're doing, we're processing ROS messages and whatnot, you could take it and make it run better potentially. We've had users use this for the MotoROS1 code anyway, use it as the basis for other applications. Obviously we prefer they stick to the ROS environment, but it's open source. You do what you want with it.
Yes, Michael River.
Yeah, so you mentioned you're publishing TF from the driver. Are you publishing like the sort of kinematically calibrated location of the tool, like the robot knows, or are you just kind of publishing TF based on normal kinematics?
We are using the robot reported TCP data. So he asked if publishing TF, if it were using the calculated value or the value from the robot. And so we are reading it from the robot API. So where it thinks it is based upon the calibration.
Is it possible to like expose the calibrated DH parameters for use in planning, something like that? It's not-
The DH parameters don't actually get calibrated in our arm. So they're, they do a calibration of the home zero position, but the DH parameter is always at a nominal, basically off the print.
You have to take the question. That's what I mean.
Repeat that one.
Yeah, the question was,
I should listen.
Sorry, the question was the timestamp of the TF. We synchronize using the micro-ROS service. We synchronize the clock of the robot controller with the clock of the client PC, and we use that timestamp when we get the timestamp at that moment as we publish. Did that answer your question?
Yeah.
Okay. Anyone else?
About the but is that a case of like if I have it's a third place, so I got a long period to stay about. Is that something a case where I can just start feeding them and then just put them all errors in the door and totally the operator? You have to really do it on the same thing and how everything that's to feed it.
So this question's about like, feeding.
Yeah.
Batch.
So the question is, if you have a larger than 200 point trajectory from a follow joint trajectory action, how do you break that up? Like I said, I know I've seen a Python script somewhere. I'm not sure how polished it is. We can, work on something, but basically that spools up another node that exposes a follow joint trajectory server, so it accepts the trajectory from, say, move it, and then it sits there in a loop, spewing out 1 point at a time to the robot controller. As the robot controller accepts them, it will process them one at a time, and if it's busy processing the previous point, it'll reply back with a failure to the service saying, I am busy, try again later. And we do have clear error codes and human readable strings for those for that purpose. I'm sorry, I didn't hear that. Yes, the slice would be incurring back on the local machine, not on the robot controller itself.
Question online from Mesh.
Okay.
What are you going to work on provisional roadmap next?
What am I working on the provisional roadmap next? That is a good question. I'm gonna say DX200 support probably, and then what I'd like to do is solicit any feedback from other users, and if we get and just see what what's in demand.
We'll take requests for which one.
Absolutely. Yeah.
All right, audience, you're ready to offer up suggestions.
Real-time position statement.
Real-time position streaming. Okay. DX200 and then real-time position streaming.
Well, sorry.
One more.
You mentioned something about like asynchronous being executed. I remember complicated stuff together, and it was as simple as like same process.
So you asked if
Setting up the asynchronous.
the process for setting up asynchronous control groups. So on the Motoman side, there is no coordination being done today. There is, to Dr. Wen's point previously, there actually is an API to do that. We're just not doing it. So the coordination would need to come from the motion planner side. And when you submit a trajectory or a trajectory point, you always have to submit data for all connected groups. So we are expecting that coordination has already been done in Move It or whatever you're planning with. And then that data gets, we just execute that as it comes in, so that when a point comes in, it is a timestamp for all groups together. Yes.
It's like an online quiet.
I can go down.
Congratulations. Thank you for coming.